The Great Pyramid holds a secret our modern science is still uncovering. This video decodes the forgotten science embedded in ancient temple geometry, a hidden language of stone and sky that will change how you see human history. We are not looking for extraterrestrial architects, but for the lost genius of our own ancestors. From the solstice alignments of Stonehenge to the perfect proportions of the Parthenon, these structures were sophisticated observatories, calculators, and models of the cosmos. You will learn how ancient builders encoded advanced mathematics, precise astronomy, and principles of physics into their sacred sites, knowledge that fragments of our textbooks are only now rediscovering. How did cultures across the globe, separated by oceans and millennia, arrive at such similar and profound understandings? What were they trying to preserve for the future? When you look at an ancient temple now, what do you truly see? That priest in the dark passageway was reading a map. The pyramid itself was the map, and the stars were its coordinates. This reveals the first and most profound layer of their forgotten science, a concept we might call the blueprint of the cosmos. For these ancient builders, the temple was far more than a house for a deity. It was a deliberate, painstakingly constructed model of the universe itself. Its walls, its angles, its very footprint on the earth were designed to resonate with the fundamental order they observed in the night sky. Think of it not as architecture, but as a kind of frozen philosophy, a three-dimensional equation written in stone. The impulse was universal. Geometry. Across continents and epochs, from the sands of Giza to the jungles of Guatemala, the same mathematical constants keep appearing, woven into the stone like a signature. The most famous of these is the golden ratio, often called phi, approximately 1.618, but this is not just a number from a math class. You can find it in the spiral of a nautilus shell, the arrangement of seeds in a sunflower, the branching of your own veins. It is a pattern of growth and harmony that nature herself uses. Researchers like historian John Anthony West argued compellingly that the ancient Egyptians did not stumble upon this ratio by accident. They understood it as a fundamental law of creation, a divine proportion. When they built, they applied it deliberately to create spaces that felt inherently balanced, dynamic, and strangely alive to the human spirit. A rectangle built with the golden ratio's proportions is simply more pleasing to our eye and mind than a random one. It feels right because it mirrors the patterns we are subconsciously surrounded by in the natural world. The Great Pyramid is a masterclass in this. Its base perimeter divided by twice its height gives you a figure astonishingly close to pi, another transcendental constant relating a circle's circumference to its diameter. This means the builders encoded the relationship between a square, the earth, and a circle, the heavens, into the very shape of the monument. These were not aesthetic choices. They were cosmological statements in stone. This language of proportions was the first key, the basic alphabet, used to write a much larger message about humanity's place within an ordered universe. But those perfect proportions were only the static score of the symphony. To hear the music, you had to be there when the sun rose. 5,000 years ago, on the shortest day of the year, a community in what is now Ireland gathered in darkness. They entered a massive grass-covered mound called Newgrange, walking down a long, narrow passageway of immense stones. At the end, in a small central chamber, they waited. And then, as if on a celestial cue, a single, narrow beam of sunlight pierced the total darkness. It streamed through a specially constructed roof box above the entrance, traveling the entire length of the passage to illuminate the inner sanctum for precisely 17 minutes. This was not luck. This was engineering on a timescale that stuns the modern mind. The builders of Newgrange designed their entire structure, a tomb and a temple, to capture the first light of the winter solstice sunrise. They did this over 5,000 years ago, aligning it with a precision that would require sophisticated tools and repeated observation across generations. This is the second breathtaking principle of the forgotten science, celestial alignment, and the field that studies it is called Archaeoastronomy. It reveals that these temples were not just models of the cosmos, they were active, functional observatories. Their doorways, corridors, and central axes were sightlines to the heavens. In Egypt, the 3 pyramids of Giza are arranged in a pattern that mirrors the 3 stars of Orion's belt, as proposed by researchers like Robert Bovell. This celestial mirroring suggests the pharaoh's souls were meant to ascend directly to those immortal stars. Further south, temples like Karnak were often aligned so that on certain days of the year, the sun would shine directly down the main axis to illuminate the statue of the god in the deepest, darkest shrine, a moment of divine renewal. Across the ocean at Choco Canyon in the American Southwest, a spiral petroglyph high on a cliff face becomes a calendar. On the summer solstice, a dagger of sunlight slices perfectly through the center of the spiral. As the year progresses, the light dagger moves, marking the equinoxes and other key dates. These alignments served a profound dual purpose. They were, first and foremost, colossal calendars. By watching where the sun or a specific star rose against a temple notch or pillar, priests could predict the flooding of the Nile, the arrival of the monsoon, or the time to plant crops. This was practical, life-sustaining knowledge, but the purpose ran deeper than agriculture. These events timed religious ceremonies, linking the rituals of the community directly to the cycles of the universe. The solstice sunrise at Newgrange likely symbolized the rebirth of the sun, a victory of light over darkness, hope in the deepest cold. This proves a deep, empirical understanding of celestial mechanics, achieved through patient, meticulous observation over centuries, long before the invention of the telescope. They mapped time itself in stone and shadow, turning their temples into instruments that connected earthly life to the eternal dance above. That solstice sunrise at Newgrange required more than just patient observation. It demanded a ruler, a very specific one, to achieve such precise alignments over hundreds of miles. The builders of these ancient sites needed a shared language of measurement. This leads us to one of the most fascinating and debated puzzles in archaeoastronomy, the search for a lost standard of length. In the middle of the 20th century, a Scottish engineer named Alexander Thom embarked on a monumental task. He personally surveyed over 600 stone circles and megalithic sites across Britain and France, meticulously recording their dimensions. What he claimed to discover was nothing short of revolutionary. Thom proposed that these diverse sites, built over thousands of years, were not laid out with random local measures. Instead, they shared a common unit of length. He called it the megalithic yard. This unit, he calculated, was approximately 2.72 feet, or about 83 centimeters. Now, this is where the story gets compelling and controversial. Thom argued that this yardstick was not a rough approximation. He found it repeatedly in the diameters and circumferences of the stone circles. For instance, many circles seemed to have a perimeter designed to be an exact whole number of these megalithic yards, often a multiple of 2.5 or 4. This suggested the builders were using sophisticated geometry, constructing circles with specific intended perimeters using this standardized unit. The implications are staggering. If Thom was correct, it points to a shared, advanced knowledge of surveying and mathematics that was transmitted across Neolithic Europe. Imagine a network of builders, from the windswept coasts of Scotland to the plains of Brittany, all using the same blueprint and the same measuring rod. This challenges the traditional view of isolated, primitive communities. It suggests a coordinating culture, a school of knowledge, or a tradition passed down through specialized guilds of astronomer priests. Of course, the megalithic yard is hotly debated. Some critics argue that Tom's statistical analysis finds patterns in what might be natural variation. They question whether a standard unit could have been maintained over such vast distances and centuries without a central authority. Could it be, they ask, that similar proportions arose independently because they are based on the human body, like the pace or the fathom? This is the core of the mystery, the tension between a common source and independent discovery. Yet, the sheer precision of the sites themselves leans toward something more organized. To move a 30-ton sarsen stone and place it within an inch of its intended position, as seen at Stonehenge, requires more than a rough estimate. It requires planning, communication, and a reliable way to translate a design from one mind to many hands. Whether it was a physical rod, a knotted cord, or a set of geometric rules, the evidence whispers of a lost system. This concept of a forgotten standard is not confined to Europe. Researchers have noted startling parallels, like the ancient Egyptian cubit and its potential relationships to the dimensions of the Earth, suggesting a possible global language of measure rooted in astronomy. The search for the megalithic yard is really a search for the mind behind the monument. It asks us to see these builders not as superstitious laborers, but as the engineers and mathematicians of their age, working with a precision we are only beginning to measure. And if they had such control over space, what secrets might they have encoded about time? The search for a common measuring rod points to a mind that saw the world as one interconnected system. This brings us to the third and perhaps most staggering principle of the forgotten science, geodetic encoding, where the temple becomes a model not just of the stars but of the Earth itself. The evidence for this is etched into the most studied monument on the planet, the Great Pyramid of Giza. When you measure its base perimeter, you get a figure of approximately 3,024 feet. Now take that number and multiply it by 43,200. Why that specific number? Because it was considered a sacred, cyclical number in many ancient traditions, representing a precessional age. The result is an astonishing 24,874 miles. This is within a fraction of a percent of the Earth's actual equatorial circumference. The pyramid's height multiplied by the same sacred number yields a value incredibly close to the Earth's polar radius. This cannot be a coincidence. It suggests the builders intentionally scaled down a fundamental measurement of our planet by a precise, meaningful ratio. They encoded a truth about the world's shape and size into the very bones of the structure. But the encoding goes deeper than simple ratios. The Great Pyramid sits at the intersection of the longest land meridian, the line of longitude that passes over the most continental landmass, and the longest land parallel, the line of latitude that does the same. It occupies a geodetic center of the Earth's landmasses. Furthermore, if you take the pyramid's latitude, approximately 29.979 degrees north, and look at the speed of light measured in meters per second, 299,792,458, the numbers mirror each other. While this particular correlation is hotly debated and may be numerological coincidence, it highlights how the pyramid's placement and proportions continue to generate profound questions. Some researchers, like historian and engineer John Mitchell, proposed the pyramid was designed as a 1 to 43,200 scale model of the Northern Hemisphere. In this model, the pyramid's apex represents the North Pole, and its perimeter matches the equator, with its shape even accounting for the Earth's slight flattening at the poles. What does this mean? It implies the builders possessed a spherical Earth concept and a remarkably accurate understanding of geodesy, the science of measuring the Earth. Thousands of years before Eratosthenes is credited with calculating the planet's circumference. This knowledge likely came from generations of celestial observation, trade, and mapping, synthesized by a priestly class who saw the Earth and heavens as a unified, measurable whole. They were not primitive people guessing at the world's shape. They were global thinkers who built a permanent record of their understanding in the most durable material they knew, stone. This principle challenges our entire timeline of scientific awareness, suggesting a lost epoch of discovery. If they could model the planet, what other invisible forces of nature did they seek to understand and perhaps harness through their sacred architecture? The principles of geodetic encoding show a mind thinking on a planetary scale, but what happens when that same mathematical precision is applied to human perception, to the very experience of beauty? For that, we must travel to the sun-drenched Athenian Acropolis and stand before the Parthenon. We often see it today as a magnificent ruin, a symbol of classical glory. But to its architects Ictinus and Callicrates, it was something far more precise, a mathematical manifesto in marble. They were not merely building a temple to Athena, they were solving a complex optical puzzle. The human eye, they understood, is not a perfect instrument. Over long distances and against bright skies, straight lines can appear to sag and columns can look pinched. So they engineered an elegant deception, a series of subtle corrections designed to create the illusion of perfect straightness and harmony. This is where the genius of the Parthenon truly lies, in its intentional imperfections. Look at the columns, they are not straight. Each one swells gently about 1/3 of the way up, a technique called intosses, which means stretching or tension. This slight curvature counteracts the optical illusion that a perfectly straight column would look concave under the weight of the massive entablature above. The columns also lean inward ever so slightly, and the entire platform, the stylobate, curves upward at the center. These are not construction errors, they are calculated refinements. If you extended the lines of the columns upward, they would meet about 1.5 miles in the sky. The platform's curve is so subtle you cannot see it with the naked eye, but you feel its effect, a sense of dynamic stability, as if the temple is rising organically from the rock. Underpinning all these visual tricks was a rigid mathematical law, the ratio of 4:9. This proportion governs almost every relationship in the building. The width of the temple to its length is 4:9. The distance between the columns compared to their diameter is 4:9. Even the vertical elements relate to the horizontal spans through this consistent ratio. This was the Greek pursuit of arete, excellence manifested in stone. The 4:9 ratio creates a rhythm, a visual harmony that feels inherently balanced and pleasing. It is the same principle as a musical chord that resonates perfectly. The architects fused the ideal forms of geometry, the circle and the square, with the lived experience of human sight. They understood that truth and beauty were not separate, but achieved through the same rigorous application of number and measure. This harmonic design became the bedrock of Western architectural philosophy for the next 2,000 years, a testament to the idea that the most profound human creations are those that speak directly to our senses through an unseen language of mathematics. It proves that the forgotten science was not just about aligning with stars or modeling the earth. It was about perfecting the human experience of sacred space. And if geometry could shape perception so powerfully in stone, what other invisible energies might these ancient builders have been attempting to channel or resonate with through their designs? That pursuit of perfect harmony extended far beyond what the eye could see, into the very air itself. Deep beneath the island of Malta lies a silent, underground temple complex known as the Hypogeum of Halsaflieni, carved from solid limestone over 5,000 years ago. In its deepest chamber, called the Oracle Room, a low whisper spoken into a small niche in the wall does something impossible. It travels, perfectly clear and intelligible, to every corner of the chamber and up through a carved hole into the temple levels above, as if the very stones are carrying the message. This is not a ghost story, it is physics. The Hypogeum is one of the most compelling pieces of evidence for a forgotten science of architectural acoustics, where temples were engineered not just for sight but for sound. The specific elliptical shape of the oracle room, its smooth, curved walls, and the resonant properties of the limestone itself were all carefully manipulated to create this phenomenon. Sound waves bounce and reinforce each other at certain frequencies, creating a standing wave that amplifies specific tones, particularly those in the range of the human voice. This was not accidental, it was a deliberate acoustic design. We find similar intentionality across the ancient world. At the ancient Greek sanctuary of Delphi, where the Pythia delivered her famous prophecies, researchers have studied the geology and structure of the site. Some theories suggest that naturally occurring ethylene gas rising from a fissure in the earth could have induced a trance-like state, but the acoustics of the space played a crucial role. The temple's placement and the shape of its inner chamber would have amplified the priestess's voice, making it resonate with an otherworldly power, transforming her utterances into the booming voice of the god Apollo for those gathered outside. In the Mayan pyramids of Central America, like the Temple of Kukulkan at Chichen Itza, a remarkable acoustic effect occurs. If you clap your hands at the base of the staircase, the sound bounces off the steep stone steps and returns as a perfect chirping echo, mimicking the call of the sacred Quetzal bird. This was almost certainly an engineered feature, a way to make the pyramid itself seem alive and responsive during ceremonies. What were they trying to achieve with this mastery of sound? The purpose was multidimensional. On a practical level, it allowed a single voice, a chant, or a ritual drumbeat to fill a vast sacred space, uniting a large congregation in a shared sonic experience. But the intention ran deeper into the realm of psychology and consciousness. Specific rhythmic drumming, chanting, or the sustained resonance within a chamber like the oracle room can influence brainwave patterns. These sonic environments could help induce states of focused meditation, trance, or what we might call heightened awareness, bridging the gap between the physical gathering and the spiritual realm. The ancient builders understood sound as a tangible, sculptural force. They shaped stone to shape vibration, using echo, resonance, and frequency to create an immersive atmosphere that blurred the line between the human and the divine. This reveals a layer of their science that we are only beginning to appreciate, one that treated the temple not as a silent monument, but as a living instrument. And if they could engineer stone to manipulate sound and mind, what other invisible natural forces did they seek to commune with or embody through their sacred geometry? The mastery of sound reveals a temple designed to transform human consciousness, but there is a fourth, even more profound layer to this forgotten science, one that moves beyond the physical into the realm of pure meaning. This is the principle of symbolism and esoteric knowledge, where geometry becomes a sacred alphabet, and the temple itself is a three-dimensional book written in shapes. To understand this, step into the entrance of a traditional Hindu temple. Before you even see the towering spire, your journey begins underfoot, with a detailed diagram etched or painted on the floor. This is a mandala, a cosmic map rendered in geometric perfection. At its center sits a square, the symbol of the ordered earth and the material world. Radiating outward are concentric circles and intricate patterns, representing celestial realms, deities, and the layers of consciousness one must traverse. The path from the temple's outer gate to the innermost shrine, where the deity resides, is a physical reenactment of moving through this mandala. It is a journey from the periphery of ordinary awareness to the center of divine unity, a spiritual ascent mapped in stone and space. This is not decoration, it is a guided meditation in architectural form. The shapes themselves are a universal vocabulary. Across cultures, the circle almost always represented the heavens, the infinite, and the cyclical nature of time. The square stood for the earth, the four cardinal directions, stability, and the material realm. The spiral symbolized evolution, journey, and the unfolding of consciousness. The act of inscribing a circle within a square, or a square within a circle, was a philosophical statement about the interdependence of spirit and matter, heaven and earth. This symbolic language reached into the heart of Western esoteric thought as well. In ancient Greece, Plato described 5 perfect three-dimensional forms, the Platonic solids, each built from faces of identical shape. He associated each solid with a fundamental element of the universe, the tetrahedron with fire, the cube with earth, the octahedron with air, the icosahedron with water, and the dodecahedron with the cosmos or ether. These were not just mathematical curiosities, they were seen as the literal building blocks of reality, the geometric templates from which all creation was formed. Similarly, in the Jewish mystical tradition of Kabbalah, the tree of life is a diagram of 10 spheres, or sephiroth, connected by 22 paths. This entire structure is a map of the divine attributes and the process of creation, descending from the infinite into the manifest world. It is a geometric blueprint for the soul's journey back to its source. These systems all share a core belief that geometry is the bridge between the material and the divine. The precise ratios and shapes were not merely for aesthetic or structural stability. They were believed to vibrate in harmony with the underlying structure of creation itself. By building according to these principles, the temple became a resonant chamber for spiritual energy, a tool for alignment not just with stars but with the very source of existence. This knowledge was often esoteric, meaning it was reserved for initiated priests, scholars, and artisans. The temple's outer form might inspire awe in the common worshipper, but its inner geometric code contained deeper teachings about the nature of the universe and the human soul's place within it. The geometry was the key to unlocking those teachings. This symbolic layer answers a lingering question: why go to such extraordinary lengths? The celestial alignments ensured cosmic timing, the sacred proportions created harmonic space, and the acoustic engineering shaped experience. But the symbolic code provided the ultimate why. It was all in service of a grand vision to create a microcosm, a perfected little world where a human being could, for a moment, step into the order of the cosmos and remember their connection to it. The temple was a machine for transcendence, built with the forgotten science of meaning itself. And if these ancient cultures shared such a sophisticated understanding of cosmic order, how did this profound knowledge seemingly vanish from the mainstream of history? But that profound knowledge of sacred geometry did not simply vanish. It may have been hiding in plain sight, formalized by a name we all recognize but born from a tradition far older. The question is a startling one. Did Pythagoras, the famous Greek mathematician, actually discover his famous theorem, or did he inherit a secret that was ancient history by his time? The evidence carved in stone and written on clay suggests the latter, pointing to a lineage of practical geometric knowledge that stretches back thousands of years before his birth. We must first look to Mesopotamia, to a small clay tablet known as Plimpton 322, dated to around 1800 BC. This Babylonian artifact is not a shopping list. It is a sophisticated mathematical table, listing pairs of numbers that form what we now call Pythagorean triples, sets of 3 whole numbers that perfectly describe the sides of a right-angled triangle, like 3, 4, 5. The Babylonians were not merely playing with numbers, they were using them for practical surveying, construction, and astronomy. They understood the relationship between the sides of a right triangle over a millennium before Pythagoras was born. This knowledge was not confined to the Middle East. In ancient Egypt, the builders of the pyramids almost certainly used the same principles. They employed specialists known as harpodonapti, the rope stretchers. These surveyors used a knotted rope divided into segments of 3, 4, and 5 units. By stretching the rope to form a triangle with those lengths, they could guarantee a perfect right angle for laying out the foundations of temples and monuments. The 3-4-5 triangle was their living, physical tool for imposing geometric order on the chaotic landscape. This practical, hands-on mastery of geometry was the true cradle of the so-called Pythagorean theorem. The Greeks, with their love of abstract philosophy and proof, did something monumental with this inherited knowledge. They formalized it. They took a rule of thumb used by rope stretchers and stonemasons and elevated it into a universal mathematical principle, proving it must hold true for every right triangle everywhere. Pythagoras himself, according to tradition, spent years studying in Egypt and Babylon, places where this applied geometry was the bedrock of sacred architecture. He likely did not discover it, but rather learned it, synthesized it, and brought it into the Greek intellectual tradition where it was given his name. This reveals a crucial pattern in the history of knowledge. Practical, empirical discovery often comes first, born from necessity in fields like construction, astronomy, and navigation. The theoretical framework, the elegant proof, comes later, codifying what the artisans already knew in their hands. The story of the Pythagorean theorem is a story of this transition, from the rope in the sand to the axiom on the page. It shows us that the mathematical genius we attribute to classical Greece was built upon a forgotten foundation, a deep antiquity where the secrets of triangles and harmony were already being used to build a world aligned with the cosmos. This lineage forces us to ask an even bigger question. If this fundamental geometric truth was known across continents, what other pillars of our science might have equally ancient and equally forgotten roots? This lineage of practical geometry raises a more tangible mystery, one you can run your fingers over. High in the Andes of Peru, the fortress of Sacsayhuamán presents a puzzle that defies simple explanation. Its walls are built from colossal blocks of limestone, some weighing over 100 tons. But these are not simple rectangles. They are polygonal, a giant's jigsaw puzzle of irregular shapes with anywhere from 6 to 12 sides, each block uniquely carved to interlock perfectly with its neighbors. The fit is so precise that for centuries, locals said not even a razor blade could slide between the stones. There are no gaps, no mortar, just immense weight and impossible geometry holding the wall together for over 500 years through earthquakes that have leveled modern buildings all around it. This is the enigma of polygonal masonry, and it appears in sacred sites across the ancient world, from the Osirian in Egypt to sites in Japan and Easter Island. It represents a forgotten science of stone that seems to border on the supernatural. How did they do it? The first challenge was quarrying. These stones were not found lying about. They were extracted from distant quarries, which implies an advanced knowledge of geology to identify sound stone and techniques for separating it from the bedrock. The mainstream theory involves using wood wedges, water, and fire to create fracture lines, a slow, labor-intensive process, but that only gets you a rough block. The second, far more perplexing challenge is the shaping. How do you carve a 100-ton block of granite, one of the hardest stones on Earth, into a complex polygonal shape with beveled edges and subtle curves, and then do it again for the next block so that they fit together like three-dimensional puzzle pieces? Traditional archaeology points to stone hammers made of even harder rock like diorite, and an immense amount of patient pecking and grinding with sand and water. This is plausible for smaller projects, but the scale and precision at Sacsayhuamán stretch this explanation to its limits. The surfaces are often smoothly finished, with no visible tool marks from pounding. This has led to alternative theories that sound like science fiction, but are born from sheer bewilderment. Some researchers have proposed the use of a now-lost plant-based chemical agent, a substance that could temporarily soften the stone surface, allowing it to be molded or shaped more easily before it rehardened. Others point to the possibility of advanced sonic or vibrational tools, using specific frequencies to resonate the stone and make it more malleable, a concept that echoes the acoustic mastery we saw earlier. Then comes the third challenge, logistics, moving these multi-ton blocks often uphill over rough terrain. The conventional idea involves ropes, log rollers, and large teams of people. Yet, the coordination required to maneuver an irregular, 100-ton polygon into an exact position against its neighbor with millimeter precision is a feat of engineering and communication that rivals any modern construction project. It implies not just brute force but a deep understanding of physics, leverage, and teamwork. When you stand before such a wall, the mainstream explanations feel incomplete. They tell us the what, the possible methods, but they struggle to convey the how at the level of flawless execution we witness. This polygonal technique was not just a style choice, it was a brilliant engineering solution. The interlocking shapes distribute weight and seismic forces far more effectively than rectangular blocks, which is why these walls still stand while others have fallen. This was knowledge born from necessity, refined to an art form. It suggests a school of masonry so advanced that its techniques have been lost to time, a practical science of stone that enabled builders to literally bend rock to their will, creating structures that were meant to last for millennia. The real mystery is not just the method, but the mind behind it, a mind that could see the final, perfect wall in a pile of raw mountain rock and know exactly how to get there. That mind which could shape stone also listened to the land itself. This brings us to the fifth and perhaps most intuitive principle of the forgotten science, the art of placement, or what many traditions call geomancy. Beyond celestial alignments and sacred ratios, the builders displayed an uncanny sensitivity to the Earth's own subtle character. They chose their sacred sites not at random, but with a deliberate eye for specific features in the landscape, locations believed to pulse with a special energy or resonance. You can see this pattern everywhere. Ancient temples crown hilltops and ridges, like the Acropolis in Athens or the mountain shrines of Peru. They cluster at the confluence of two rivers, a sacred junction in cultures from India to the Celtic world. They rise from natural springs or are built directly over underground watercourses, and in some remarkable cases, they align with curious geological or even magnetic anomalies. This practice suggests a belief in what some researchers and traditions refer to as telluric currents, or the more popular idea of ley lines, hypothetical alignments of spiritual or earth energy that crisscross the globe. Whether these lines are a literal, measurable force or a powerful metaphorical concept for spiritual pathways, the intention behind the sighting is clear. The builders sought a marriage between their architecture and the living geology. They were looking for power spots. How did they identify these places? The methods were likely a blend of keen observation and practiced intuition. They might have watched where animals congregated or noted where certain plants thrived in unusual patterns. They would have felt the wind, listened to the echo of a valley, and tasted the water. One practice often cited in folklore and some historical accounts is dowsing, the use of a forked rod or pendulum to detect subtle subterranean vibrations, often from underground water. While modern science is skeptical, the empirical success of finding water through such means is documented, suggesting a sensitivity to gradients in the local magnetic or electric field that a practiced individual might subconsciously detect. The builders were reading the landscape as a living body with veins of water, bones of rock, and points of concentrated vitality. A hilltop offered a natural connection to the sky and a defensive, awe-inspiring vantage. A water confluence symbolized the merging of forces and provided the life-giving element central to purification rituals. A place with a magnetic anomaly, where a compass behaves oddly, might have been felt as a zone where the ordinary rules of the world bent slightly, a true thin place between realms. This geomantic science was a profound blending of geology and cosmology. It held that the Earth was not a dead substrate, but a conscious partner in the sacred work. By placing their temple on a powerful node, they believed they could amplify its purpose, grounding celestial harmony into the terrestrial plane and tapping into a natural wellspring of vitality. The structure then acted like a lens, focusing and directing these ambient energies for the benefit of the community. This is why so many of these sites, even in ruins, still hold a palpable sense of peace or power for modern visitors. They are located where the earth itself speaks most clearly. The art of placement completes the picture of the temple as a truly holistic instrument. It was aligned with the stars above, built with the proportions of creation, engineered for sound and sight, and finally, rooted into a chosen point of terrestrial power. It was a conscious act of weaving human endeavor into the very fabric of the natural world. But if these sites were so carefully chosen and constructed as harmonic instruments, what happened when the music stopped? What forces could possibly dismantle such a deeply rooted scientific and spiritual tradition? The art of placement finds its ultimate expression in a city of stone reclaimed by the jungle. Angkor Wat is more than a temple. It is a colossal astronomical clock, its very stones measuring the breath of the sun. At dawn on the spring equinox, from a vantage point west of the complex, the sun rises in perfect alignment over the central lotus bud tower of the main shrine. This is no accident of orientation. The entire 5-kilometer-long moat and the Grand Western Causeway are aligned along an east-west axis with such precision that on both equinoxes, the sun climbs directly over the central sanctuary, a moment of supreme celestial balance engineered into the landscape. But the solar alignments are just the beginning of its timekeeping function. The temple's architecture is a physical encyclopedia of Hindu cosmology, built during the reign of King Sacsayhuamán II in the 12th century. Its most famous bas-relief, the churning of the ocean of milk, is not merely a mythological scene, it is a precise celestial map. The Devas and Asuras pulling on the serpent represent the opposing forces that drive precession, the slow wobble of Earth's axis that cycles through the constellations over 26,000 years. The temple's central towers are arranged to mirror the stars of the Draco constellation as they would have appeared at the time of its construction, anchoring the monument to a specific moment in the great celestial wheel. Most profoundly, Angkor Wat encodes the concept of the yugas, the vast, cyclical ages of Hindu cosmology. The temple's measurements are based on a sacred unit called the Hat, and scholars like Elena Manica have demonstrated that these dimensions correspond to the durations of the 4 yugas. The distances from key gates to the central sanctuary reflect the ratios of these epochs, from the short, virtuous golden age, the Satya Yuga, to the longer, spiritually diminished ages that follow. The outermost gallery wall, for instance, relates to the Kali Yuga, our current age of conflict, its length symbolizing its duration. This means a walk from the outer entrance to the inner sanctum is a symbolic journey backwards through cosmic time toward a primordial state of unity. This is geometry on an epic, almost philosophical scale. The builders were not just marking the annual journey of the sun, they were modeling deep time itself, compressing hundreds of thousands of mythical years into a walkable plan. The sheer scale of Angkor Wat, with its massive moat representing the cosmic ocean, allowed them to inscribe these vast cycles into a comprehensible human experience. It stands as perhaps the ultimate testament to the forgotten science, a machine built to make the abstract, cyclical nature of time physically visible and spiritually tangible. It prompts a final, haunting reflection. If these cultures possessed such a unified, sophisticated science of cosmos, earth, and mind, why does it feel like a secret we are only now rediscovering? What happened to this interconnected way of seeing the world? That shell on the beach is a mathematical manuscript. Its elegant spiral expands in a rhythm so precise it can be described by a simple series of numbers 1, 1, 2, 3, 5, 8, 13, and so on. This is the Fibonacci sequence, where each number is the sum of the two preceding it. But the true magic is in the ratio between these numbers. As the sequence progresses, the ratio of one number to the one before it gets closer and closer to that divine proportion we discussed earlier, the golden ratio, approximately 1.618. This pattern is not an abstract curiosity, it is a fundamental algorithm of growth. You find it in the arrangement of leaves on a stem for optimal sunlight, in the unfurling of a fern, and in the majestic swirl of a galaxy. It is nature's signature, a code for building structures that are both strong and efficient. Ancient architects, keen observers of the world around them, recognized this pattern as sacred. They saw it as the visible handwriting of the Creator, a blueprint for beauty and stability inherent in the fabric of life. So they did something extraordinary. They began to copy it. They transcribed this natural code from the organic world into the mineral world of stone. In the soaring vaults of Gothic cathedrals, like Chartres or Notre Dame, the immense rose windows are not just dazzling art, they are geometric sermons. Their intricate tracery often follows the Fibonacci progression, with rings of petals or lobes increasing in number according to the sequence. This design creates a visual rhythm that pulls the eye inward toward the center, mimicking the centripetal force of the Nautilus spiral, and generating a sense of harmonious, radiant order that feels both mathematically profound and spiritually uplifting. Travel to India and observe the silhouette of a Hindu temple spire, the Shikara. It rarely rises as a simple cone. Instead, it is composed of a series of horizontal layers that diminish in size as they ascend. The proportional relationship between these tiers, the reduction in their width and height, frequently follows the golden ratio derived from the Fibonacci sequence. This gives the spire an organic, budding quality, as if it is not merely a built structure but a living form pushing skyward, a stone mountain peak blooming from the earth in perfect natural proportion. Even the Parthenon, for all its rigorous rectilinearity, whispers this sequence. Scholars analyzing its floor plan have noted that the progression of spaces from the outer colonnade to the inner chamber, the relationship of widths to lengths in its various compartments, often resolves to ratios found within the Fibonacci series. This subtle embedding of organic mathematics within a framework of strict geometry would have created a subliminal sense of rightness, a feeling that the temple was not an alien imposition on the landscape, but a natural outgrowth of it, as inevitable as a shell on the shore or a pine cone on the forest floor. This was the ultimate goal, to build artifices that felt instinctively true. By weaving the Fibonacci sequence and its resulting ratio into their designs, these master builders were not just applying a formula, they were invoking a principle. They were aligning human creation with the deepest patterns of creation itself, ensuring their temples resonated with the same timeless, generative logic that builds a sunflower or a hurricane. In doing so, they crafted spaces that did not fight against nature but conversed with it, creating an architecture that felt less like a construction and more like a revelation. The stone itself became a clock face, and light was its moving hand. Twice a year, in a spectacle carved from a mountainside, the forgotten science reveals its most theatrical principle, the integration of light and shadow. On the banks of the Nile, the great temple of Abu Simbel stands as a monument to this solar choreography. For most of the year, its inner sanctum lies in profound darkness, 60 meters deep into the rock. But on two specific mornings, around February 22nd and October 2022, a miracle engineered 3,200 years ago occurs. As the sun rises over the eastern horizon, a single, razor-sharp beam of sunlight pierces the temple's long entrance corridor. It travels through the outer hall of colossal statues, past the supporting pillars, and deep into the heart of the mountain. Finally, it reaches the innermost shrine, where 4 statues sit in eternal stillness, depicting the deified pharaoh Ramesses II alongside the gods Amun, Ra-Horakhti, and Ptah. For approximately 20 minutes, the sunlight illuminates three of these figures, Ramesses, Amun, and Ra, bathing them in a radiant glow. The fourth god, Ptah, associated with the underworld and darkness, remains forever in shadow, untouched by the sun. This is not a happy accident of architecture. It is a precise calculation of solar geometry, a permanent appointment between the sun and the stone, set by ancient astronomer priests. The entire temple axis, the slope of the floor, and the height of the doorway were designed to capture the sun's angle at a very specific point in its annual journey, likely corresponding to the king's birthday and coronation day. The event transforms the static temple into a dynamic, time-keeping spectacle. It uses the most powerful, universal source of energy, sunlight, as a sacred special effect. This mastery of illumination was a tool of both science and theater. By controlling light, the builders controlled focus and meaning. In the dim interiors of Egyptian temples, a shaft of light falling on a hieroglyphic text or a god's face during a festival would have felt like a direct communication, a divine spotlight confirming the ritual's cosmic timing. This principle extends far beyond Egypt. In the Pantheon in Rome, the great oculus, a circular opening in the center of the dome, acts as a colossal sundial. The beam of sunlight it admits sweeps across the interior, marking the hours and seasons on the patterned floor and walls, turning a civic building into a public celestial clock. Across the Atlantic, at the Mayan site of Tezcatlipoca in Mexico, the Temple of the Seven Dolls is famous for its equinox alignment. On the spring and autumn equinox, the rising sun shines directly through the temple's doorways, east and west, creating a tunnel of light that perfectly frames the sunrise for those standing inside. These architects were not merely building structures, they were building experiences. They understood that light sculpts space and defines mood. The calculated interplay of brilliance and darkness created moments of awe, revelation, and connection. It made the cosmic cycles visible and visceral, turning the annual journey of the sun from an abstract concept into a dramatic, participatory event witnessed by the entire community. The temple was no longer just a place to worship the sun. It was a place where the sun actively participated in the worship. This deepens our understanding of their science, revealing it as a holistic art that engaged all the senses to map the sacred onto the fabric of daily life. If they could so perfectly orchestrate the sun's rays, what other invisible environmental forces did they seek to harmonize within their sacred spaces? The precise numbers carved into that shell on the beach find their monumental echo in the desert. To move from the elegance of natural spirals to the staggering scale of the Great Pyramid is to confront the most debated mathematical riddle in archaeology. The figures are so precise they border on the uncanny. Take the pyramid's original height, estimated at around 481 feet. Now consider its base perimeter, roughly 3,024 feet. If you take that perimeter and divide it by twice the height, you do not get a random figure. You get a number extraordinarily close to pi, approximately 3.1416. This means the builders, whether they expressed it as a fraction or not, engineered a structure where the perimeter of the square base relates to the height as the circumference of a circle relates to its radius. It is a geometric metaphor of profound sophistication, squaring the circle in stone. Then there is the golden ratio, phi. Look at the pyramid's face. The distance from the apex straight down the center of a triangular face to the center of a base side, called the apothem, measures about 612 feet. The distance from that center point on the ground out to the midpoint of a base side is roughly 378 feet. Divide the apothem by that half base, and you arrive once more at a figure hauntingly close to 1.618, the divine proportion. Two of the most fundamental, irrational constants in mathematics, both seemingly embedded in the same structure. The question that has divided scholars for over a century is stark. Were these brilliant encodings, or are they simply the accidental byproduct of a much simpler building rule? The mainstream Egyptological explanation centers on the sect, an ancient Egyptian unit of slope. They argue the builders chose a simple, practical sect, a ratio of vertical rise to horizontal run, to define the pyramid's angle. A sect of 5.5 palms per cubit, for instance, yields the pyramid's familiar 52-degree slope. From that single, pragmatic decision, the complex ratios for pi and phi emerge automatically as geometric consequences. In this view, the builders were brilliant engineers, not abstract mathematicians, and the constants are a happy coincidence of their chosen, elegant proportion. Yet the counter-argument is compelling. Coincidences of this magnitude, achieved on a scale of 2.3 million stone blocks, strain belief. To achieve the pi relationship, the builders did not just pick any slope, they selected the one specific angle out of infinite possibilities that produces it. The precision required to maintain that exact angle across 13 acres of foundation, with errors measured in fractions of an inch, speaks to an intention that transcends simple slope stability. It suggests a conscious desire to memorialize a cosmic principle. Could they have known pi? Absolutely. We have evidence from the Rind mathematical papyrus that the Egyptians used a practical value for pi, 22 divided by 7, for everyday calculations. Could they have known phi? While no explicit written formula survives, their art and architecture show a repeated preference for proportions that align with it, suggesting an aesthetic and possibly ritual understanding of the ratio as a generator of harmony. So, which is it, intention or artifact? Perhaps the most satisfying answer lies in the middle. The ancient master architects likely operated on multiple levels of knowledge simultaneously. The sect provided the practical, buildable instruction for the workforce, but the choice of that specific sect, from a priestly or philosophical perspective, was deliberate because it yielded these deeper, symbolic harmonies. The pyramid was both a brilliantly engineered tomb and a three-dimensional treatise on the mathematics they observed governing the natural world. The numbers were not a secret code for us to find, but a sacred statement for their gods, embedding the order of the cosmos into the pharaoh's eternal resting place. The enduring mystery is not merely in the numbers themselves, but in the mind that could conceive of uniting practical engineering with transcendental mathematics on such an impossible scale. Granite core samples from ancient Egyptian quarries tell a silent, stubborn story. Pulled from deep boreholes, these cylindrical stones are etched with spiral grooves so clean and uniform they look machined. Modern engineers have tried to replicate them using copper tube drills with sand abrasive, and while they can achieve similar marks, the speed and depth of the ancient cuts remain baffling. The grooves indicate a feed rate, the speed at which the drill bit advanced into the rock, that suggests either immense, sustained pressure or a technology far more efficient than simple copper and sand. This is the first tangible clue in a workshop of lost techniques, a place where the how becomes as mysterious as the why. Alongside these drill cores, we find other tools that seem mismatched to the task. Scattered around sites like the unfinished obelisk at Aswan are countless diorite pounders, fist-sized balls of a stone harder than granite. The mainstream explanation is that workers patiently pecked away at the granite surface with these pounders, gradually shaping it over years. Yet, when you look at the mirror-smooth finishes on statues like the seated coffer or the interior walls of granite sarcophagi, surfaces so flat and precise they can reflect light, the idea of achieving that perfection through billions of random hammer blows strains credibility. The tool marks that do exist are often shallow, parallel striations, more consistent with a sawing or grinding motion than with pounding, and here lies a profound absence. Bronze, the hardest metal commonly available to the Egyptians, is not hard enough to cut granite. a bronze chisel would simply deform against the quartz crystals in the stone. So if not bronze chisels, and if diorite pounders alone seem insufficient for the finest work, what was really happening in those quarries and workshops? This gap in the historical record has led researchers to hypothesize about forgotten branches of material science. One compelling idea involves thermal shock. By building a fire against a granite surface and then rapidly cooling it with water, the stone expands and contracts unevenly, causing thin layers to fall off. This technique could explain how large blocks were initially rough-shaped from bedrock. Another, more speculative theory points to plant-based chemical agents. Historical accounts, like those from the 1st century naturalist Pliny the Elder, mention substances that could soften stone. While often dismissed as legend, some modern experiments with organic acids found in certain plants have shown a mild etching effect on limestone, though nothing conclusive on granite. Perhaps the most intriguing hypothesis connects back to the acoustic mastery we explored earlier. Could specific, amplified sound frequencies have been used to resonate stone, temporarily altering its crystalline structure or making it more amenable to shaping with simpler tools? The concept finds echoes in modern ultrasonic machining. The absence of these advanced tools from the archaeological record is telling. It suggests a knowledge that was either so specialized it required no unique, preservable tools, or one that was deliberately guarded and ultimately lost. Perhaps the greatest tool was the technique itself, a refined understanding of stone's properties, leverage, and teamwork, passed down through generations of master artisans. The coarse samples and the impossible finishes stand as quiet, physical testimony to a lost chapter, not just in history, but in the story of human ingenuity itself. That lost workshop of stone was governed by a hidden logic, a blueprint for building worlds within worlds. This is the 7th principle, modular design and fractal concepts, where the temple does not merely stand, it grows, unfolding from a single seed of geometry into a universe of stone. To see this in its purest form, we must travel to the heart of a Hindu temple and understand its genesis. It all begins with the Garbhagriha, the womb chamber, a small, dark, perfectly square room that houses the deity. This is the sacred seed, the absolute center. But a temple cannot end there. It must express the journey from that singular point of divinity outward into the manifest world. So the architects used a set of strict geometric rules, laid out in ancient texts called the Shilpa Shastras, to expand that seed. They did not design each new layer from scratch. Instead, they applied a repetitive, modular system. Imagine taking that central square and surrounding it with a series of concentric frames, each one a slightly larger, more elaborate version of the last. Pillars, walls, and gateways are added not arbitrarily, but according to proportional formulas where every dimension relates back to the core module of the Garbhagriha. This modular expansion culminates in the Vimana, the towering, often mountain-like spire that rises directly above the inner sanctum. Look closely at a South Indian Vimana, and you will see it is not a smooth pyramid. It is composed of distinct horizontal tiers, each one a smaller, self-similar version of the one below it, receding toward the peak. Each tier is adorned with miniature architectural elements, tiny false windows, diminutive pillars, and carved niches that mirror the full-scale features of the temple's lower levels. This is where the concept becomes truly profound. It mirrors what modern mathematics calls a fractal. A fractal is a pattern that repeats itself at every scale. Think of a snowflake where the same crystalline shape appears in the tiniest branch and the overall six-armed form, or a coastline where the pattern of bays and inlets looks similar whether you view it from a satellite or a pebble on the beach. The temple is a man-made fractal, the same geometric relationships, the same decorative motifs, the same architectural logic, repeat from the grand sweep of the spire down to the intricate carvings on a single doorframe. This approach was genius on multiple levels. Practically, it simplified the monumental task of construction. Artisans could work on standardized, repeatable units, mastering one element and then replicating its principles at different sizes. It was a system that allowed for incredible complexity without descending into chaos. But the purpose was far more than logistical. It was a philosophical and visual metaphor of staggering depth. The temple, through its fractal design, became a model of the cosmos as described in Hindu thought, a universe of infinite complexity and diversity that nonetheless arises from a single, simple, unified source, Brahman. The journey from the small, dark, unified Garbhagriha outward through the repeating, expanding modules to the soaring Vimana mirrors the process of creation itself, the one becoming the many. It teaches that the entire cosmos, in all its vastness, is built from the repetition and combination of fundamental principles. When you stand before such a structure, your eye is drawn upward, following the repeating patterns that seem to both grow and recede simultaneously, creating a sense of boundless ascent. It is architecture that visually explains infinity. This fractal logic is not confined to India. We see echoes of it in the repeating arches of a mosque's arcade, each arch a smaller world framing the next, or in the nested gables of a Khmer temple. It represents a universal insight into how complexity is built, not through random accumulation, but through the elegant, recursive application of a simple rule. The temple becomes a living demonstration that from a single point of sacred geometry, an entire ordered universe can unfold, a universe where every part reflects the whole. A fractal temple in India and a solar monument in Egypt speak in different tongues, yet their grammar feels hauntingly familiar. From the banks of the Nile to the jungles of the Yucatan, from the plains of Salisbury to the riverbanks of the Ganges, we find the same sacred obsessions, the same fingerprints of a profound scientific mind. The question this global pattern forces upon us is perhaps the greatest of all. Were these cultures isolated geniuses, or were they distant cousins inheriting fragments of a much older, shared legacy? The evidence laid out across the world is compelling. Consider the pyramid form itself. The stepped pyramids of Saqqara in Egypt and the towering temple of the sun at Teotihuacan in Mexico share more than a silhouette. Both are precisely aligned to cardinal directions and encode astronomical knowledge in their layout. The Maya, like the Egyptians, tracked Venus with obsessive precision and built observatories like El Caracol to map its complex cycles. In Neolithic Europe, the builders of Stonehenge demonstrated a knowledge of the 19-year Metonic cycle, the same lunar cycle later formalized by the Greeks to predict eclipses. Most strikingly, the concept of precession, the slow, 26,000-year wobble of Earth's axis, appears subtly encoded in myths and monuments from the Hindu yugas to the Greek legend of the ages of man, and arguably in the celestial alignments of Giza and Angkor Wat. This is not simple sun worship, this is advanced, long-term celestial mechanics. The argument for independent genius is strong and respectful. It holds that intelligent humans observing the same sky and facing the same fundamental needs for calendar keeping and spiritual meaning would naturally arrive at similar solutions. This is the principle of convergent cultural evolution, where necessity and human ingenuity birth parallel ideas across the globe. The pyramid shape is a stable, logical way to build tall, a universal solution to an engineering challenge. Solar alignments are the most obvious way to mark time. Perhaps these similarities are a testament not to a single source, but to the universal spark of human curiosity. Yet the counterargument whispers of a lost epoch. The similarities are not just in broad concepts, but in specific, sophisticated knowledge. The precise use of the golden ratio, the complex understanding of precession, the geodetic encoding of the Earth's dimensions, these are not intuitive discoveries. They require sustained, recorded observation over generations. Could cultures separated by oceans and millennia have each independently spent centuries calculating the same obscure astronomical cycles and embedding them into architecture with the same mathematical constants? The diffusionist theory suggests a different story, one of a common, ancient source civilization, a lost progenitor of this sacred science, whose knowledge was carried across the world by migration, trade, or catastrophic dispersal. This idea, popularized by figures like Plato with his tale of Atlantis, suggests a global cataclysm, perhaps at the end of the last ice age around 12,000 years ago, fragmented a once unified understanding. Survivors, scattered to different corners of the world, would have carried with them the core principles of this science, which then evolved into the distinct but related traditions we see in historical times. The truth likely resides in a complex middle ground. Some knowledge, like basic solar alignments, could certainly arise independently, but the transmission of more complex, non-intuitive data, like specific stellar alignments for precession or precise geodetic ratios, strongly suggests some form of contact or shared inheritance, even if indirect. Perhaps there was not one single source, but a network of early seafaring cultures, a forgotten Bronze Age internet, exchanging ideas along trade routes that stretched further than we've dared to imagine. The megalithic yard of Europe, the cubit of Egypt, and similar standard measures from other regions hint at a possible ancient system of measure that facilitated this exchange. To ponder this is to open a door to a radically different view of human history. It suggests a deep antiquity where scientific discovery was not linear and progressive, but cyclical, with peaks of understanding that were reached, lost, and painstakingly rebuilt from fragments. Our current scientific age may not be the first to grasp the cosmos with such clarity, but perhaps one of many in a long, forgotten conversation between humanity and the stars. That global conversation between humanity and the stars was not a public broadcast. It was a whispered lesson in a sealed chamber. The profound science we see encoded in stone was not common knowledge, even in its own time. It belonged to a hidden world of initiation, a rigorous and secretive education reserved for a select few. This knowledge was the domain of elite priestly castes and closed brotherhoods, the guardians of cosmic law. In ancient Egypt, this institution was known as the Per-Ankh, the House of Life. Far more than a library, it was a combination of university, scriptorium, and research center attached to major temples. Here, scribes and priests underwent decades of training. They mastered the sacred hieroglyphs, each considered a vessel of divine power. They studied mathematics from papyrus scrolls, learning the geometry needed to calculate land areas after the Nile's flood or to design a temple's perfect proportions. Astronomy was not theoretical. It was a nightly vigil charting the decans, the star clocks that divided the night, and plotting the erratic path of planets against the fixed tapestry of constellations. This was not education for a career, it was a lifelong consecration to maintaining Mat, the cosmic order, through precise ritual and exact knowledge. A mistake in the stars could mean a mistake in the calendar, and thus a failure of the harvest and the favor of the gods. The knowledge was power, literally. It gave the priestly class the ability to predict the Nile's flood, to speak for the gods, and to design the pharaoh's pathway to the afterlife. It was too potent to be trivialized. Similar structures existed across the ancient world. In India, the Gurukul system placed a student, a shishya, in the home of a guru for years of immersive study. The curriculum, especially for those destined to become temple architects or astrologer priests, included the Sholba Sutras, texts that contained complex geometric rules for constructing altars, and implicitly, the roots of algebraic and Pythagorean principles. The relationship was sacred, the transmission oral and experiential, ensuring the student internalized the wisdom before ever applying it. And in the Greek world, centuries later, Pythagoras founded not a public school but a secretive, ascetic brotherhood in Croton. His followers swore oaths of silence, shared all property communally, and believed numbers were the divine language of reality. The famous theorem was just one fragment of a much larger, mystical philosophy they guarded closely. The story of a member being drowned for revealing the secret of irrational numbers may be legend, but it underscores the cult-like protection surrounding this wisdom. Why such intense secrecy? The reasons were multifaceted. On a practical level, it maintained quality control and social stability. Only those who had proven their dedication, intellect, and character over years could be trusted with knowledge that could literally move mountains and command nations. Esotericism also preserved the symbolic potency of the knowledge. When a geometric principle is understood as a direct expression of the divine mind, revealing it to the uninitiated risks profaning it, reducing sacred truth to a mere tool or trick. This protective secrecy, however, carried a profound historical cost. It made the entire edifice of this ancient science incredibly fragile. When these mystery schools were disbanded, when temples were destroyed or converted, when the lineage of gurus or priests was broken by war, famine, or cultural shift, the living thread of understanding was severed. The knowledge did not evaporate, but it retreated. It survived not in open textbooks, but in the only vaults durable enough to withstand the collapse of civilizations, the encoded architectural forms we have been studying all along. The temple itself became the last surviving teacher, a silent syllabus in stone waiting for a future age to learn its language anew. That silent syllabus in stone speaks a numerical language far deeper than simple measurement. Beyond the elegant curves of the golden ratio and the stark alignments of celestial mechanics lies an eighth principle, where numbers themselves become vessels of sacred power. This is the world of symbolic numerology and gematria, a layer of the forgotten science where mathematics merges with mythology, and every dimension whispers a story. Here, a number is not just a count, it is a key to a hidden dimension of meaning, woven directly into the fabric of temple geometry. Consider the number 108. In Hindu and Buddhist traditions, this is not a random figure. It is considered supremely auspicious, a number of completion. Ancient astronomers noted that the average distance from Earth to the Sun is roughly 108 times the Sun's diameter. The same ratio appears with the Moon. Furthermore, there are said to be 108 sacred syllables in certain mantras, and 108 points defining the sacred human body according to yogic anatomy. This cosmological and physiological symbolism was directly translated into architecture. Many Hindu and Buddhist temple designs incorporate the number 108 in their layout. You might find 108 pillars supporting a hall, or a circumambulatory path requiring 108 steps. The design of mandalas often features this number in their intricate geometry. By building with this dimension, the architects were not just creating space, they were aligning the temple with the perceived harmonies of the cosmos and the inner landscape of the practitioner. It was a way of building resonance into the very blueprint. Now, shift your gaze to the number 72. This figure emerges from the grandest celestial clock of all, the precession of the equinoxes. As Earth's axis slowly wobbles over a cycle of approximately 26,000 years, the position of the Sun at the equinox shifts backward through the zodiac constellations at a rate of about 1 degree every 72 years. This 72, therefore, became a sacred code for this vast world-age cycle. We find it embedded in Egyptian tradition, connected to the story of Osiris, whose body was said to have been divided into 72 parts. In Hebrew Kabbalistic tradition, the name of God, the Tetragrammaton, was sometimes associated with 72 divine names or angels. This processional number subtly informed sacred architecture, influencing proportions and the counts of statues or columns, linking the temple to the slow, majestic turn of the great year. Then there is the number 40, a pillar of meaning in Abrahamic traditions. It represents a period of trial, preparation, and transformation. The Great Flood lasted 40 days and nights. Moses spent 40 days on Mount Sinai. The Israelites wandered for 40 years, and Jesus fasted for 40 days in the wilderness. This symbolic period of testing and renewal found its way into sacred design. While less about a specific geometric constant like pi, the number 40 might govern the number of steps in a pilgrimage stairway, the repetitions of a ritual circumambulation, or the dimensions of a courtyard, embedding the narrative of spiritual journey into the physical act of moving through the space. This practice of gematria, assigning numerical values to letters, allowed for even more intricate encoding. In Greek and Hebrew, where letters served as numbers, the name of a god or a sacred phrase could be summed to a numerical value. That value could then be mirrored in a temple's measurements, creating a hidden mathematical signature of the divine presence the building was meant to house. The floor plan's length, the height of a column, or the count of ceiling panels could all be living expressions of a holy name. This reveals the ultimate purpose of this numerical layer. It was a bridge between the seen and the unseen. The precise, surveyable dimensions of the temple also corresponded to an invisible landscape of myth, astronomy, and theology. The geometry did not just create a beautiful or stable building, it told a story, it held a prayer, and it mapped a cosmology all at once. For the initiate who understood the code, walking through the temple was like reading a three-dimensional sacred text, where every number pointed to a deeper truth. These encoded numbers and secret teachings found their most expansive canvas not in enclosed temples, but under the open sky of ancient Britain. Here, the principles of sacred geometry were scaled to the horizon itself, etched into the rolling landscape with circles of towering stone. Sites like the sprawling complex of Avebury and the quietly powerful rollright stones represent a different expression of the same cosmic science, one where the architecture is the land and the temple has no roof but the heavens. This is the profound art of landscape geometry, where individual circles, long ceremonial avenues, and burial mounds were not isolated monuments, but precise points in a vast, intentional design. The builders of these megalithic complexes were thinking on a scale we are only beginning to map. At Avebury, the largest stone circle in Europe, the monument is not a single ring but a series of concentric circles and avenues that engage with the entire surrounding topography. The great outer bank and ditch, still visible today, create a massive boundary that embraces a portion of the village, suggesting the sacred and the communal were deeply intertwined. Leading from the southern entrance, the West Kennet Avenue stretches for over a mile, its paired standing stones guiding processions toward the mysterious Silbury Hill, the largest artificial mound in prehistoric Europe. The placement of these features was not random. Researchers, building on the pioneering surveys of Alexander Thom, have identified that the positions of circles, mounds, and sighting stones often form precise geometric relationships across miles of countryside. They used the land itself as their drawing board, connecting sacred nodes with invisible lines of sight and measured distance. Thom's meticulous work revealed that the builders employed sophisticated geometry long before the Greeks formalized it. Many stone circles are not perfect circles at all, but carefully constructed ellipses, egg shapes, or flattened rings, requiring a grasp of complex Pythagorean triangles to lay out their perimeters. To create an ellipse, you need to establish two focal points and maintain a constant total distance from those points to the perimeter, a concept demanding advanced planning and rope and peg geometry. The presence of these precise shapes, repeated across hundreds of sites, argues against the idea of primitive, rough-hewn construction. It points to a society with specialist surveyors, a shared unit of measure like the debated megalithic yard, and a deep desire to impose perfect geometric forms upon the natural world. The sheer physical effort involved shouts the importance of this knowledge. Consider the rollright stones in Oxfordshire, a smaller but equally potent complex. The King's Men stone circle is composed of weathered limestone blocks, each one dragged from a local outcrop. The effort to move these multi-ton stones, to position them in a specific geometric pattern on a specific hilltop, represents an enormous investment of communal labor and time. This was not a task undertaken lightly. It tells us that this geometric and astronomical understanding was central to the community's identity and spiritual life. The entire society, from the planners to the laborers, was mobilized to create these vast, open-air temples. Their purpose was alignment, not with a single doorway, but with the entire cosmos as viewed from that place. The horizons around these circles are often punctuated by notches, peaks, or distant hills that mark the rising and setting points of the sun and moon at key times of the year, like the solstices or the more complex lunar standstills that occur every 18.6 years. The stone circle acted as both an observatory and a ceremonial theater, framing these celestial events for gathered participants. In this landscape geometry, the sacred science becomes a communal act of world-building, where an entire community collaborated to stitch celestial order into the very fabric of their homeland, creating a permanent resonance between the earth below and the cycles above. The stones of Avebury were not the only way to sculpt a sacred landscape. Sometimes the most profound geometry was not carved from rock, but channeled through water. To understand the full scope of this forgotten science, we must expand our vision beyond the temple walls to the sacred city itself, where geometry became the blueprint for survival and spiritual order. Consider the ancient metropolis of Mohenjo-Daro, rising from the Indus Valley over 4,000 years ago. This was not a haphazard collection of homes. It was a masterclass in sacred urban planning, built on a precise grid of streets oriented to the cardinal directions. Beneath those orderly streets lay its true engineering marvel, a sophisticated, geometrically designed sewer system. Homes were connected to a network of brick-lined drains, all laid with calculated slopes and angles to ensure efficient flow. These conduits fed into larger, covered channels that ran beneath the main avenues, complete with manholes for maintenance. This was not merely a practical sanitation system. It was an expression of a civilization's core value, ritual purity. The precise control of water, its clean delivery and its swift removal, was a form of applied sacred geometry, ensuring the physical and spiritual cleanliness of the entire community. It turned the entire city into a kind of temple with its own internal, flowing anatomy. This concept of water as sacred geometry reaches its zenith at Angkor. The Temple of Angkor Wat is merely the glittering centerpiece of a vast hydraulic empire. The Khmer engineers transformed the landscape into a colossal machine of water and symbolism. They constructed an intricate network of massive reservoirs called barrays and hundreds of kilometers of geometrically precise canals. The largest barray, the West Barray, is an artificial lake measuring 5 miles long and 1.3 miles wide, its edges forming near-perfect rectangles. This was not just a water tank, it was a cosmological statement. The barrays represented the mythical oceans surrounding the cosmic mountain of Hindu belief, with the central temple as Mount Meru. The water's reflective surface doubled the temple's image, merging the earthly structure with the celestial realm in a daily visual miracle. But the function was as brilliant as the symbolism. This hydraulic network was a feat of applied mathematics and civil engineering. It mastered the monsoon's deluge, capturing seasonal rains to prevent catastrophic flooding. It stored this water to irrigate rice paddies throughout the dry season, supporting a population that may have exceeded 1 million. The precise angles of the canal banks, the calculated volumes of the reservoirs, and the graded slopes for water distribution all required a deep, practical understanding of geometry and hydrology. This mastery turned a volatile tropical environment into a controlled, fertile paradise, the literal lifeblood of the civilization. Here, the line between temple geometry and civil engineering completely dissolves. The sewer of Mohenjo-Daro and the reservoir of Angkor were both sacred instruments. They served the triad of ancient necessity, ritual purification, practical flood control, and the symbolic representation of cosmic waters. To design them required the same intellectual rigor as aligning a pyramid to a star, the same grasp of angles, volumes, and proportions. This reveals the forgotten science as a holistic system. It was not an abstract priesthood dabbling in star charts while ignoring the mud below. It was an integrated world view where the principles of cosmic order had to be made manifest in every aspect of life, from the path of wastewater to the storage of monsoon rains. The city itself, in its streets and its waterways, became an extension of the temple's sacred geometry, a living organism engineered in harmony with both celestial cycles and terrestrial forces. If they could orchestrate water on such a monumental scale, weaving utility and symbolism into the land itself, what other fundamental elements did they seek to harmonize through their geometric vision? Leonardo da Vinci's famous drawing of a man within a circle and a square is not merely a work of Renaissance art. It is a powerful echo, a memory in ink, of a principle so ancient and universal it forms the very foundation of sacred architecture. This is the ninth principle, anthropometry, where the human body itself becomes the ultimate template, the living ruler from which all sacred proportions are derived. For these ancient builders, humanity was not separate from the cosmos. It was a perfect microcosm of it. Therefore, to build a temple in harmony with the universe, you first had to understand the divine geometry of the human form. This was not a vague inspiration, it was a precise mathematical system. In Egypt, the fundamental unit was the royal cubit, approximately 20.6 inches. This was not an arbitrary length. It was defined as the distance from a man's elbow to the tip of his extended middle finger, with subdivisions based on the width of a palm or a finger. The Great Pyramid's base side is famously 365 cubits, linking the human measure directly to the solar year. Every block, every chamber, every passage was conceived in this bodily unit, making the entire monument a scaling up of human proportion into a mountain of stone. Travel to India, and you find an even more elaborate system detailed in the Vastu Shastras, the ancient architectural texts. Here, the basic module is the angular, often defined as the width of a finger. 8 angular make 1 tala, the width of a palm, but the system truly comes alive with the Purusha, the cosmic man. The ideal temple was laid out as a mandala, a geometric grid, and this grid was superimposed upon the image of the Purusha lying face down. Different parts of the temple complex, from the innermost shrine to the outermost wall, corresponded precisely to different parts of this cosmic body. The sanctum sanctorum, the garbhagriha, often aligned with the heart or the head, the seat of consciousness. The various pillars, walls, and gateways corresponded to limbs and joints. This meant that to walk through the temple was to move through a giant architectural body, a body that was simultaneously a map of the cosmos and a mirror of your own. The purpose was profound unity. By building to human scale, but a perfected, divine human scale, the architecture created an intimate resonance. You did not feel dwarfed or alienated by the space. You felt embraced by it, as if the temple was an externalization of your own highest potential. The proportions felt right because, in a very literal sense, they were you. The columns were spaced according to the rhythm of a human stride. The heights of doorways related to the stature of an ideal figure, and the entire plan reflected the symmetry we see when we stand with arms outstretched, just like Da Vinci's Vitruvian Man. This principle transformed worship from a passive act into an embodied experience. You weren't just visiting a house of God, you were walking into the symbolic body of the divine, and in doing so, you were reminded that the same sacred geometry that structured the stars and the seasons was also the blueprint for your own being. The temple became the ultimate mirror, asking a silent, powerful question of every person who entered. If the cosmos is built in the image of a divine body, and this temple is built to that same measure, then what does that make you? That silent question posed by the temple's mirrored proportions leads us to a final, staggering layer of their knowledge, one that required them to think not in years but in millennia. The precession of the equinoxes is astronomy on its grandest scale. Picture the Earth not as a perfect, stable top, but as a slowly wobbling, spinning toy. This wobble causes the axis around which our planet rotates to trace a wide circle in the sky over a cycle of approximately 25,920 years. This means the star that marks our north celestial pole changes over epochs, from Theoben in the time of the pyramid builders to Polaris today. More subtly, it causes the position of the sun against the backdrop of stars at the equinox to slowly drift backward through the 12 constellations of the zodiac, spending about 2,160 years in each. This drift is so slow it amounts to just 1 degree every 72 years, utterly imperceptible within a single human lifetime. Yet, with astonishing consistency, this vast celestial clock, and its key numbers 72 and 25,920, echo through ancient myth and stone. In Egyptian mythology, the story of Osiris, the god of death and rebirth, involves his body being divided into 72 parts by his brother Set. This is a startlingly precise mythological parallel to the astronomical fact. In the Hindu concept of the yugas, the great world ages, the numbers again align with precessional math. The Greek philosopher Plato, in his dialogue The Timaeus, speaks of a perfect year, completed when all the celestial bodies return to their original positions, a concept many scholars link to this grand cycle. But the most compelling evidence is architectural. The Great Pyramid's internal passages have long been a subject of intense study. The descending passage, for instance, is angled at approximately 26 degrees. Some researchers, like Robert Bovell, have noted that this angle, along with the alignment of the southern shaft from the King's Chamber, pointed directly to the star Al-Nitak, the central star of Orion's belt, around 2500 BCE. But they propose this was not a snapshot of the sky in the pyramid's construction era, but part of a larger, precessionally timed design. The slow drift of Orion over centuries would have been tracked and encoded. The number 72 itself may be embedded in the pyramid's geometry, with some analyses of its base perimeter and height yielding multiples of this precessional key. To even recognize this cycle requires continuous, meticulous observation of star positions over centuries, a tradition passed down with flawless accuracy from priest to priest for dozens of generations. It implies an institution of astronomy that maintained precise records for longer than our entire recorded history since the fall of Rome. This timescale is what fundamentally challenges our narrative. Conventional history tells us that Hipparchus, a Greek astronomer in the 2nd century BCE, was the first to document precession. But if the number 72 is woven into Egyptian myth and their architecture millennia earlier, it suggests the phenomenon was not discovered but remembered. Encoding precession in stone is an act of profound patience and purpose. It means the builders were not just marking the annual journey of the sun for planting seasons. They were mapping the journey of our entire solar system through the galaxy, anchoring their civilization to a timeline of cosmic rebirth that spans 26,000 years. They were building monuments meant to remain meaningful not just for a dynasty, but for a full turn of the great celestial wheel. This asks us to reconsider the very origins of scientific inquiry. pointing to a forgotten epoch of observers who looked to the stars not with primitive wonder, but with the disciplined gaze of long-term cosmic cartographers, recording a truth so vast it could only be entrusted to myth and the eternal geometry of mountains made by human hands. That cosmic map drawn in stone began to fade from human memory. The integrated science of the temple, a unified vision of cosmos, earth, and spirit, did not vanish in a single cataclysm. Its decline was a slow fragmentation, a great forgetting caused by a confluence of powerful historical forces. The first and perhaps most profound shift was philosophical. In the ancient Mediterranean world, a new way of thinking began to take root, one that would fundamentally reshape humanity's relationship with knowledge. This was the rise of empirical philosophy, championed by thinkers like Aristotle. Its power was undeniable. It sought to understand the natural world through observation, logic, and categorization, separate from the dictates of myth or temple ritual. This was the brilliant dawn of what we now call the scientific method. But this new dawn came with a long shadow. In the process of separating the measurable world from the realm of the sacred, a critical unity was severed. The stars were no longer seen as divine beings whose movements dictated ritual, but as physical objects whose paths could be calculated. Geometry was no longer the sacred language of creation, but a practical tool for engineering and trade. This intellectual divorce, while enabling incredible advances, meant the profound spiritual context that gave the old science its deepest meaning began to erode. The why of the temple's alignment became less important than the how of its construction. The second devastating blow was physical, the systematic loss of the repositories where this holistic knowledge was stored. The Great Library of Alexandria stands as the most famous symbol of this catastrophe. For centuries, it served as the nearest thing the ancient world had to a universal archive, collecting scrolls from Egypt, Greece, India, and beyond. Within its halls, the astronomical records of Babylonian priests likely sat alongside the geometric treatises of Greek philosophers and the architectural manuals of Egyptian builders. Its destruction, a slow process of fires and conflicts over several centuries, was an incalculable loss. Countless unique texts, the cumulative written memory of millennia of integrated observation, turned to ash. Similar fates befell other centers of learning, from the House of Wisdom in Baghdad to the scriptoriums of remote monasteries. Each fire, each sack of a city, didn't just burn paper, it broke another link in the chain of transmission. With the living teachers gone and their sacred texts destroyed, the knowledge survived only in scattered, disconnected fragments. This led directly to the third factor, the specialization of disciplines. As the unified worldview shattered, the individual strands of the temple science unraveled and went their separate ways. Astronomy became the domain of mathematicians charting planetary motions for navigation and calendar reform. Its connection to sacred architecture reduced to historical curiosity. Geometry flourished in the hands of engineers and artists, but its symbolic, cosmological dimensions were largely stripped away, preserved only in cryptic texts and secret societies. Architecture evolved into a profession governed by new styles, materials, and structural principles, its ancient role as a cosmological machine fading into legend. The master builder who once understood the stars, the stones, and the soul as one continuous system was replaced by the architect, the astronomer, and the priest, each speaking a different, isolated language. So where did the flame of this unified knowledge go? It did not go out entirely, it retreated. It survived in the hidden streams of esoteric tradition. The geometric principles and symbolic codes lived on in the guarded rituals of mystery schools, in the symbolic compass and square of Masonic lodges where master builders preserved sacred geometry as moral allegory, and in the intuitive, passed-down rules of thumb used by Gothic cathedral masons. These traditions kept the forms alive, but often lost the original, profound scientific context that explained why those forms held power. The great unity, the understanding that a temple's proportion resonated with a planetary orbit, that its alignment echoed a star's path, and that its space could alter consciousness, became a collection of separate mysteries. We were left with the magnificent, silent stones, and the haunting intuition that they contained a secret we had once known in full, but could now only glimpse in disconnected fragments. The silent stones of those ancient temples may have been designed not just to be seen, but to be heard at a frequency beyond our normal hearing. This brings us to a 10th and deeply speculative principle, the idea of resonance and vibration. Modern science gives us a fascinating window into this possibility through a field called cymatics, the study of visible sound. When you spread sand on a metal plate and play a specific, pure tone through it, the sand doesn't just jump randomly. It organizes itself into intricate geometric patterns. A low frequency might create a simple circle. A higher pitch can form complex mandalas of hexagons, stars, or concentric rings. The sound is literally writing geometry with matter. This is not magic, it is physics, demonstrating that vibration has a direct, formative relationship with shape. Now consider the ancient builders, masters of observation. They would have witnessed natural examples of this principle everywhere, in the concentric ripples from a dropped stone in a pond, in the hexagonal cells of a honeycomb formed by the collective vibration of a hive, even in the spiral patterns of galaxies. What if they deduced that sacred geometry was not just a symbolic map of the cosmos, but its actual architecture, the frozen pattern of a fundamental cosmic vibration? This leads to a compelling theory that they engineered their temples not only with visual proportions, but with acoustic dimensions, carefully tuning chambers like giant stone instruments. Some researchers point to the phenomenon known as the Schumann resonance, the extremely low-frequency electromagnetic pulse that naturally occurs in the cavity between the Earth's surface and the ionosphere, often called the planet's heartbeat. This fundamental frequency, around 7.83 Hz, is within the range of human brain waves, specifically alpha waves associated with relaxed meditative states. Could certain sacred spaces, through their specific dimensions and materials, have been designed to amplify or harmonize with this terrestrial pulse? The Great Pyramid's King's Chamber, built from resonant granite, has been the subject of such speculation, with some analyses suggesting its dimensions might create a standing wave at or near this frequency. The intent would have been profound, to literally tune the temple to the Earth itself, making it a place where an individual could physically feel in sync with the planet's natural rhythm. Beyond the Earth's frequency, the theory extends to harmonic frequencies that could directly influence human consciousness. We know that rhythmic drumming, chanting, and sustained tones can alter brainwave patterns, guiding the mind into states of deep focus or transcendence. If a chamber's dimensions were mathematically derived to resonate at a specific harmonic, say a frequency that promotes theta waves linked to deep meditation or creative insight, then the very space would become a tool for shifting awareness. The Oracle Room in Malta's Hypogeum, with its extraordinary acoustic amplification, is a prime candidate for such intentional design. The builders may have understood that by shaping the stone in that exact elliptical form, they were creating a resonant cavity that would enhance specific vocal tones during rituals, using sound as a direct vehicle to alter the psychological state of the participants. This vibrational layer of the forgotten science bridges the gap between the cold mathematics of geometry and the warm, lived experience of the sacred. It suggests the temple was more than a model of the cosmos. It was an instrument for interacting with it, using the physics of vibration to touch the human mind and spirit. The patterns they carved in stone may have been attempts to capture the signature of the universe's own song, and to build spaces where that song could be heard, felt, and lived. The echoes of that cosmic song are no longer silent. A new generation of explorers, armed not with chisels but with satellites and algorithms, is listening. They are the pioneers of a field that bridges millennia, a discipline known as archaeomathematics. This is not treasure hunting. It is a meticulous, interdisciplinary science that combines archaeology, astronomy, advanced mathematics, and cutting-edge technology to decode the silent language written in ancient stone. Their work is the modern chapter of our story, a patient effort to rebuild the framework of a forgotten science, one precise measurement at a time. Consider the groundbreaking research of Jane B. Sellers, an independent scholar who turned a lifetime of fascination into rigorous analysis. By meticulously studying Egyptian texts and temple alignments, she presented compelling evidence that the ancient Egyptians not only understood the slow wobble of Earth's axis, the precession of the equinoxes, but that they encoded its key numbers into their mythology and monument orientations. Her work moved the discussion from speculation into the realm of statistically significant celestial pattern recognition, forcing a reevaluation of what these cultures were truly capable of observing over vast stretches of time. In Italy, Professor Giulio Magli, an archaeoastronomer, applies the precise tools of physics and geometry to sacred landscapes worldwide. He doesn't just look at a single temple's doorway, he analyzes entire ceremonial complexes as integrated astronomical machines. Using sophisticated software, he can recreate the exact sky over Giza or Teotihuacan on any date in history, testing alignments with a digital precision that earlier researchers could only dream of. His work on the celestial geography of the Roman Empire and the pyramid fields of Egypt demonstrates how deeply connected urban planning was to cosmic order, revealing a layer of intentional design that is invisible to someone simply standing on the ground. And then there is the provocative, paradigm-shifting work of Robert Bovell. His Orion correlation theory, suggesting the three pyramids of Giza mirror the three stars of Orion's belt as they appeared around 10,500 BC, ignited global debate. While controversial, Bovell's core contribution was monumental. He urged the world to see these structures not as isolated tombs, but as parts of a unified, sky-ground blueprint designed with a deep understanding of precessional time. He forced academia and the public alike to think on a scale of millennia, not just dynasties. These researchers, and many like them, form the vanguard of archaeomathematics. Their toolkit is revolutionary. Satellite imagery and LiDAR, which uses laser pulses to see through jungle canopy, are revealing hidden alignments and geometric city plans on a continental scale. Three-dimensional laser scanning captures monuments with sub-millimeter accuracy, allowing for the detection of subtle architectural refinements, like the precise curvature of a platform or the exact angle of a shaft that the human eye could never discern. Most importantly, powerful statistical analysis separates meaningful patterns from random chance. When 100 temples across a civilization all show a solstice alignment within a degree of arc, that is not coincidence, it is a cultural mandate proven by numbers. This modern validation is a quiet revolution. It is slowly confirming that the ancient claims of sacred harmony were not poetic metaphor, but the result of exacting empirical science. The stories of gods and stars were their way of recording data, and the temples were their permanent public reports. Each scan, each celestial simulation, each statistical correlation is a piece of the puzzle being clicked back into place. We are not imposing modern ideas onto ancient minds. We are finally developing the tools to understand the sophisticated language they were speaking all along. The work of these pioneers does more than rewrite history books. It rebuilds a bridge to a different kind of intelligence, one that saw number, star, and spirit as a single, magnificent whole. And as this bridge is rebuilt, it forces us to ask a final, urgent question. What does this recovered wisdom mean for us here and now? in a world that has forgotten how to listen to the geometry of the sky. The discoveries of archaeomathematics leave us with a profound and delicate question. If we now see the temple builder as a master geometer and astronomer, does that somehow diminish the spiritual power of their work? Does explaining the mechanics of the solstice alignment drain the magic from the sunrise at Newgrange? This is a crucial crossroads in how we interpret the past, and the answer requires a careful, nuanced perspective. Framing their achievements solely as primitive science risks a grave misunderstanding, one that projects our modern, compartmentalized worldview onto a culture that saw no such divisions. For them, the precise tracking of Venus was not separate from venerating it as a god. Calculating the golden ratio was not an abstract exercise, but a way of building a vessel worthy of the divine presence. Their science was the physical expression of their faith, and their faith was the philosophical framework that gave their science its ultimate purpose. To recognize the mathematical genius behind the Great Pyramid does not strip it of mystery, it deepens it. It asks us to marvel not at imagined alien technology, but at the staggering human capacity for sustained observation, collaboration, and symbolic thought. The real wonder shifts from how they lifted the stones to why they went to such impossible lengths to encode cosmic constants. Their spiritual intent becomes even more awe-inspiring when we realize it was pursued with such rigorous intellectual discipline. This recovered knowledge should not lead us toward cultural appropriation or simplistic narratives. The ancient astronaut theory, while entertaining, is ultimately a disservice. It robs these cultures of their own genius, outsourcing their accomplishments to external forces instead of grappling with the magnificent, untold story of human innovation. It is a form of intellectual surrender. Similarly, plucking sacred geometric symbols from their original cultural and ritual context to serve modern trends often strips them of their depth and meaning. A respectful integration of this knowledge means holding two truths in balance: that these were deeply spiritual people, and that they were also brilliant empirical scientists. They did not see a conflict between those roles because for them, the material and the spiritual were two sides of the same cosmic coin. Their legacy challenges our own fragmented way of seeing the world. In an age where science and spirituality are often portrayed as opposing forces, their temples stand as silent, monumental proof of a different path. A holistic vision where measuring the stars and seeking the divine were parts of one unified quest for understanding. This changes our view of human history from a simple line of progress to something more like a spiral, where profound insights into the nature of reality have been reached, lost, and rediscovered in different forms across the ages. The final lesson etched in the geometry may not be about forgotten technology, but about a forgotten way of knowing, one that sought truth with both the precision of the mind and the reverence of the heart. The principles of sacred geometry did not vanish with the ancient world, they simply changed their architectural clothing. Centuries after the last stone was laid at Angkor and Giza, in the misty forests of medieval France, a new kind of mountain began to rise toward the sky, built not for a pharaoh, but for the glory of God. The Gothic cathedral represents the most spectacular flowering of this geometric tradition in the Western world, a living proof that the forgotten science had been kept alive, passed down through secretive guilds of master masons. To walk into Chartres Cathedral is to step inside a three-dimensional geometric theorem designed to trigger transcendence. Its very footprint is a sermon in stone, laid out with a compass and a straightedge. The entire floor plan is generated from a simple, profound act, the squaring of the circle. Builders would begin with a central square symbolizing the earthly realm. Using the square's diagonal as a radius, they would draw a circle representing the divine heavenly sphere. The intersection points between these shapes then dictated the positions of the nave, the transepts, and the apse. This generative geometry meant every part of the structure was in harmonic proportion to the whole, a fractal growth from a sacred seed. But the geometry was not just in the plan, it was underfoot. Embedded in the stone floor of the nave lies the great labyrinth, a single, winding path inlaid in black and white stone. This is not a maze with dead ends, but a unicursal path, a deliberate, meditative journey of 11 circuits leading to a rosette center. Walking its 262 meters was, and still is, a form of pilgrimage in miniature, a physical prayer where the body's movement traces a sacred geometric pattern, turning the faithful worshipper into a living part of the cathedral's symbolic machinery. Then you lift your eyes. The stone skeleton of Chartres is filled with light, specifically a luminous celestial blue found in its legendary stained glass windows. The positioning of these windows was not arbitrary. Modern archaeoastronomers have noted that at the summer solstice, a specific beam of sunlight, filtered through a particular pane, strikes a precise flagstone on the floor. This is the ancient language of celestial alignment, speaking through colored glass and solar angles. The famed blue Virgin window seems to hold a light that comes from elsewhere, a vibration of color achieved through a lost recipe of cobalt and chemistry, making the very air inside the cathedral feel charged with a presence that is both mathematical and mystical. This was the ultimate goal of the Gothic masters, to use geometry and light as engines of spiritual ascent. The soaring vertical lines of the pillars, the ribbed vaults that draw the eye ever upward, the way light dissolves solid stone into panels of jeweled narrative, all worked in concert. They understood that precise proportion, what they called sacred measure, could evoke a feeling of sublime harmony, while controlled, divine light could overwhelm the senses. The knowledge to do this was not publicly archived, it was the protected trade secret of the Masonic lodges. These guilds passed down their geometric rules, their secrets of the craft, from master to apprentice through hands-on practice and symbolic ritual. The compass and square were not just tools, they were emblems of a cosmic order the Mason was duty-bound to replicate. In building Chartres, they were not merely constructing a church, they were compiling a centuries-long encyclopedia of sacred geometry, a last glorious testament to the idea that to build for the divine, you must first understand the silent language of number, shape, and star. Their success is measured not in years, but in the still palpable gasp of any visitor who enters, feeling the stone itself pull the soul toward the light. But with a field this captivating, a shadow inevitably follows. The line between groundbreaking archaeomathematics and elaborate pseudoscience can become dangerously thin. How do we, as curious observers, separate the meticulous work of a researcher like Jane Sellers from the seductive, often viral claims of fringe theorists? This is not about shutting down wonder, but about sharpening it, equipping ourselves with a simple toolkit for critical thinking. The first and most vital tool is source evaluation. When you encounter a claim about a pyramid's power or an ancient global civilization, pause and ask who is making this claim and what is their evidence. Legitimate researchers publish in peer-reviewed journals, present at academic conferences, and welcome scrutiny from their peers. Their work builds slowly, brick by brick, on verifiable data. In contrast, many sensational claims originate from popular books, documentary specials, or social media posts that bypass this rigorous process entirely. They often rely on a charismatic narrator rather than a body of reproducible evidence. Next, we must master a crucial logical distinction, the difference between correlation and causation. Just because two things appear connected does not mean one caused the other. The classic example, ice cream sales and drowning incidents both rise in the summer. This is a correlation, but one does not cause the other. A hidden third factor, hot weather, drives both. In ancient geometry, we see this constantly. A pyramid's base perimeter might correlate with the Earth's circumference when multiplied by a certain number, but did the builders intend that, or is it a numerical coincidence that emerges from their simpler building ratio? Correlation invites investigation, but it is not by itself proof of intention. We must be especially wary of numerical cherry-picking. This is when someone tests dozens, even hundreds, of mathematical operations on a monument's dimensions until they find a combination that produces a number that seems significant, like the speed of light or a planetary orbit. If you search through enough random data with enough different formulas, you will eventually find a seeming pattern purely by chance. Rigorous analysis works the opposite way. It starts with a hypothesis based on cultural context, then tests that specific idea against the measurements. It asks, does this one meaningful ratio appear consistently and intentionally? This discernment does not require us to be closed-minded. Healthy skepticism is not dismissal, it is the engine of good science. It asks for evidence, welcomes debate, and changes its view when presented with stronger data. It protects the true wonder of this field, which is astonishing enough on its own. The verifiable precision of the solstice alignment at Newgrange, the demonstrable acoustic properties of the hypogeum, the statistically significant use of the golden ratio in art across cultures, these are the genuine marvels. They do not need layers of speculative mathematics to be profound. Their power lies in what we can measure, repeat, and confidently say our ancestors achieved. Navigating this landscape ultimately requires a balance, an open heart to feel the mystery these sites evoke, and a sharp, critical mind to evaluate the stories we are told about them. The greatest respect we can pay to the ancient builders is to seek the truth of their accomplishments with the same rigor they applied to the stars. That final lesson of balance invites us to step beyond the stone and into the mind itself. The 11th principle of this forgotten science ventures into its most speculative yet deeply personal frontier, the geometry of consciousness. This is the idea that the sacred spaces we have been exploring were not just models of the cosmos or calendars of stone, but were deliberately engineered environments, machines for enlightenment, designed to directly influence the human mind and perception. Could the specific angles, proportions, and patterns of a temple act upon our brain states, quieting mental chatter and opening doors to different ways of experiencing reality? Modern research in environmental psychology offers a compelling starting point. Studies consistently show that the spaces we inhabit have a profound psychological impact. Rooms with high ceilings can promote feelings of freedom and abstract thought, while low ceilings often foster focus and intimacy. Natural, flowing forms tend to reduce stress, whereas harsh, chaotic geometries can induce anxiety. The ancient builders, through millennia of intuitive observation and ritual practice, may have been the original masters of this psycho-architecture. They were not just building for gods, but for the human nervous system. The most direct evidence for this intentional design comes from the persistent use of the mandala across Eastern traditions. A mandala is far more than a beautiful circular diagram. In meditation practices, it serves as a precise visual tool for focusing the mind. The intricate, symmetrical geometry gives the restless intellect a single, complex point of engagement. As the meditator gazes upon the mandala, the mind's habitual scattering of thoughts is gently drawn into the ordered pattern. The concentric circles and radiating squares provide a visual pathway, guiding awareness from the periphery of distraction toward a still, silent center. This process can induce states of deep calm and heightened awareness, a form of geometric hypnotism that has been utilized for thousands of years. Now, transpose that two-dimensional mandala into 3 dimensions. This is exactly what a Hindu or Buddhist temple is, a mandala you can physically enter and walk through. The journey from the outer gate, through a series of increasingly sacred courtyards and halls, to the dark central sanctum, is a ritual recreation of the meditative journey inward. The fractal repetition of shapes, the harmonic proportions, and the controlled play of light and shadow all work in concert to overwhelm the ordinary senses with order, reducing external noise and turning perception inward. The hypothesis becomes breathtaking. These temples were sensory filters. By controlling every visual and spatial input with sacred geometry, they created an environment where the normal, distracted state of consciousness could not easily persist. The chaotic external world was replaced by a realm of perfect, predictable pattern. In such a space, the mind, seeking novelty and threat, finds none. Its internal chatter slowly settles. This cultivated inner silence was the fertile ground for what different cultures have called mystical experience, communion with the divine or transcendent awareness. The temple, in this view, transforms from a passive container for ritual into an active, precision tool for inner exploration. It uses the universal language of shape and number to perform a kind of psychic tuning, aligning individual consciousness with the perceived order of the cosmos. This final principle does not diminish the spiritual, it grounds it in a profound understanding of human psychology. It suggests the ultimate goal of all that celestial alignment and harmonic proportion was not just to map the heavens, but to replicate its perceived stillness within the human soul. The temple was the interface where the geometry of the outer universe met the geometry of inner space, engineered to show they were, in the end, the same. The quiet, centering power of those sacred spaces points toward a question for our own time. What have we lost in our rush toward the purely functional, and what can we, in an age of steel, glass, and algorithmic design, learn from those ancient masters? Their forgotten science offers not blueprints to copy, but timeless principles to rediscover, principles that speak directly to human well-being. The first is the return to human scale. Ancient geometry was anthropometric, rooted in the body. Today, many of our urban environments feel alienating precisely because they ignore this. We navigate canyons of sheer glass that reflect no human proportion, or live in modular units that prioritize density over dignity. The ancient lesson is to measure our world against ourselves again. The 20th century architect Le Corbusier, for all his modernism, sensed this lack. He developed the modular, a system of proportions based on the human figure and the golden ratio, attempting to reintroduce a harmonic scale to industrial design. While imperfect, his effort highlighted a deep yearning, a need for our surroundings to feel like an extension of our own form, not a rejection of it. The second principle is the masterful integration of natural light and cycles. Our ancestors didn't just build with light, they choreographed with it. Today, we spend our days under the static hum of fluorescent tubes, in sealed boxes that divorce us from the sun's journey. The ancient approach teaches us to design apertures, not just windows, to welcome the dynamic play of sunlight and shadow, to let the seasons mark time on our floors and walls. This reconnection to diurnal and annual rhythms has a profound, calming effect on our circadian biology and our psyche. Third is the intentional use of harmonic ratios for psychological support. We now have studies showing that rooms with specific proportions, often those aligning with the golden ratio or simple musical harmonies, are consistently rated as more beautiful and restful. The chaotic, jarring angles of some contemporary architecture can induce subconscious stress, while harmonious spaces promote calm and focus. This isn't mysticism, it's environmental psychology. The ancient builders were the original practitioners of this field, intuitively crafting spaces that supported specific states of mind, from communal gathering to solitary contemplation. Finally, there is the principle of biophilic connection, of weaving the natural world into our built environment. The temples were not just aligned with nature, they were often built from it and decorated with its forms. Modern thinkers like architect Christopher Alexander, in his seminal work A Pattern Language, argued passionately for this return. He advocated for designs that create sequences of space, use natural materials, frame garden views, and allow inhabitants to feel the sun and breeze, patterns that make a building feel alive and grounded. This is the ultimate lesson, to see architecture not as a machine for living, but as a living intermediary between humanity and the cosmos. It asks us to build not just shelters, but habitats, places that nurture the whole person by honoring the deep, geometric truths written into our bodies, our minds, and the turning world. In relearning their language of stone and sky, we might just remember how to build a world that feels like home. Even with all we have learned, the stones guard their deepest secrets. The most profound legacy of this forgotten science may not be the answers it provides, but the breathtaking questions it leaves hanging in the air, questions that continue to draw researchers back to dusty sites and dimly lit archives. These are not failures of investigation, but the very fuel for discovery, the permanent mysteries that remind us the story is far from over. First, the enduring enigma of logistics. We can theorize about ramps and rollers, but the sheer physical reality of moving a 200-ton granite block, like those in the King's Chamber of the Great Pyramid, from a quarry hundreds of miles away, and then lifting it precisely into place 150 feet in the air, defies simple explanation. The coordination, the engineering, the sheer force of will required for such a task remains a humbling puzzle. How did they achieve such flawless joins between multi-ton stones that no mortar was needed, and a sheet of paper cannot slip between them? We have plausible methods, but the flawless execution on such a scale whispers of a refined, perhaps lost, art of practical physics. Then there is the puzzle of orientation. How did ancient cultures, from the Neolithic builders of Stonehenge to the architects of Teotihuacan, determine true north with such astonishing accuracy, often within a fraction of a degree, long before the magnetic compass? Some methods, like using the circumpolar stars or the shadow of a gnomon, are known, but the precision achieved suggests a level of observational rigor and a tradition of error correction that we are still piecing together. This was not a casual alignment, it was a foundational act of cosmic ordering, and its exact technical process remains partially obscured. Perhaps the largest, most tantalizing mystery of all is the pattern itself. The global recurrence of the pyramid form, the shared obsession with solstice alignments, the eerily similar use of the golden ratio and precessional numbers. Does this point to a common source, a lost progenitor civilization, as some suggest? Or is it the magnificent result of convergent cultural evolution, where intelligent minds observing the same sky and facing similar spiritual questions arrived at parallel solutions? The evidence can be read both ways. The sheer sophistication of some shared concepts, like the slow wobble of Earth's axis, which takes 26,000 years to complete, argues for some form of transmitted knowledge. Yet the profound differences in culture, language, and purpose between, say, the Maya and the Egyptians argue for powerful independent genius. This debate is the heartbeat of the field, and it may never be fully settled. These unanswered questions are not a dead end, they are an open invitation. They are why new technologies like LiDAR scanning that reveals hidden city grids beneath jungle canopies, or isotopic analysis that traces stone to its exact quarry, are so thrilling. Each tool offers a new lens, potentially capable of turning a centuries-old assumption on its head. The greatest discovery may still be waiting, not in a hidden chamber, but in a new way of seeing the data we already have. The mysteries persist not because the ancients were hiding something from us, but because their integrated way of knowing the world, where science, art, and spirit were one, is a language we are still learning to speak fluently. Every unanswered question is a thread left dangling, waiting for a future hand to pick it up and continue the weave. This journey does not end when the video fades. You are now holding a key, a new way of seeing. The most exciting chapter in this story is not buried in the past, but waiting for you to write it in the present. You have become a modern explorer, and the world is still filled with these silent, geometric puzzles. Your role begins with a simple shift in perspective. Next time you visit an ancient site, a local stone circle, or even an old cathedral in your own city, go with a different set of eyes. Instead of just seeing a monument, look for the intention. Stand at the entrance and ask yourself, where does the sun rise on this axis? Notice the shapes that repeat, the proportions of the spaces. Use your smartphone not just for a photo, but as a tool. A simple compass app can show you if a structure is aligned to cardinal directions. There are even dedicated apps that let you overlay the path of the sun or stars on your camera view, allowing you to check potential alignments in real time. This is not about proving a theory, but about cultivating a personal connection to the intelligence embedded in these places. The rediscovery of this science is a collaborative, ongoing project, and your curiosity is a vital part of it. Dive deeper with the work of the scholars who have dedicated their lives to this search. Read the accessible works of researchers like John Anthony West on Egypt, or the detailed analyses of archaeoastronomers like Giulio Magli. Let their findings be a starting point for your own questions, not an end point. Question the standard narratives you encounter in guidebooks or museum plaques. They offer one layer of truth, but the geometric and celestial layer invites you to look further. Share what you notice. Talk about the strange alignment you saw, the repeating pattern you found. In online forums or local history groups, your observation might be the piece that helps someone else solve a piece of the puzzle. Most importantly, study the universal language they used. You do not need a degree in mathematics to appreciate sacred geometry. Start by drawing a simple vesica piscis, the shape formed by two overlapping circles, or by observing the Fibonacci spiral in a pine cone or sunflower in your backyard. This practice trains your mind to see the world as they saw it, as a web of interconnected patterns and ratios. By becoming an active observer, you do more than learn history. You participate in a timeless human endeavor, the quest to understand our place within a beautifully ordered cosmos. The stones have been waiting for someone to listen. Now you know how to hear them. We began as detectives before a pyramid, piecing together clues in stone and shadow. We end now not with a final answer, but with a humbling revelation that reframes our entire story. Our ancestors were far more than primitive worshippers or superstitious laborers. They were master scientists charting celestial cycles across millennia. They were consummate artists sculpting light and space into experiences of awe. They were profound philosophers seeking to understand humanity's place within a vast, ordered universe. The forgotten science we have traced is their universal language, a lexicon written not in words, but in the deliberate angles of a passageway, the perfect curve of an arch, and the silent alignment of a wall with a distant star. This language speaks of a humanity deeply connected, one that saw no dividing line between the rhythm of the planets and the rhythm of the human heart. They achieved a synthesis we have since fragmented, a holistic way of knowing where precise measurement and spiritual reverence were two sides of the same sacred coin. To stand in the king's chamber and feel its resonant silence, or to witness the solstice light pierce a dark passage, is to touch the outcome of that synthesis. It is an intelligence that engaged the full human being, mind, body, and spirit in a single, magnificent project. This legacy is not merely a relic to be catalogued. It is a mirror held up to our own age. In a world that often pits science against spirit, data against meaning, their work offers a powerful alternative vision. It shows us that curiosity about the cosmos and a yearning for the sacred can be, and perhaps were meant to be, partners in the same great quest for understanding. Their temples were the ultimate expression of that partnership, machines for wonder built with the tools of reason. Let this knowledge settle not as a closed chapter, but as an open invitation. Let it inspire a deeper, more respectful awe for the ingenuity of those who walked this earth long before us. Let it rekindle a childlike curiosity about the hidden patterns in the world around you, from the spiral of a shell to the path of the sun through your own window. And let it remind you that every time you look up at the night sky, you are participating in the same ancient human conversation that once moved mountains to mark a star's return. If this journey has reshaped your view of history, share it with a fellow explorer. We have countless more mysteries to uncover together. Tell us in the comments which temple's silent geometry now speaks to you the loudest.